Swayam Prabha. Digital India. Educated India.
Okay, welcome back. Welcome back to the course Geology and Soil Mechanics. So, in the last class we have seen the sieve analysis, grain size distribution and hydrometer analysis. So, and then we just started the consistency of clay with and Atterberg limits. So, basically the consistency of clays is defined or is categorized by 4 states. First one is the liquid state, and then plastic state, and then semi solid state and solid state. So, there are 4 states by if you vary the water content or the moisture content of the soil or the clay soil, then you will be getting 4 different states, and those states are defined or associated with consistency of clays. Now, basically how you define these 4 states? First one is the liquid, as I told you, liquid state, plastic state, semi solid state and solid state. Now, if you come back to this figure, so basically you add water to a particular clay sample and you make a slurry. So, this is something like your liquid form if you get it. So, basically that comes under this zone. So, this is your liquid state. So, and then you reduce the water content from the sample, and then slowly from the liquid state the soil sample will be entering the plastic state. Okay. So, when basically you can deform the material. So, in the liquid state you do not have the option to deform it, rather it will flow, it will lose its strength. So, it will be a complete fluid kind of thing. When you reduce the water from this liquid state, basically slowly or gradually you will be entering the phase or the state which will be defined as plastic state. So, in the plastic state basically you can deform the soil. Suppose if you want to make a ball of the soil sample, or if you really want to do the clay modeling. So, basically you need to have the state which belongs to plastic state. Then from plastic state basically if you further reduce the water content or the moisture from the soil, then basically you will be entering the semi solid state. So, as you see, this plot is basically volume versus water content. So, as you reduce the water content basically you are also getting the reduction in volume. So, your volume is getting reduced, and so in the liquid state it will be having the maximum volume, and slowly it will be reducing to the plastic state and then semi solid state. So, then basically in the semi solid state once you reach at this point, then if you further reduce the water content, suppose in this direction you are reducing the water content, but you are not getting any change in volume, and that is known as solid state. So, in your solid state no matter whatever water content you are considering, so you will not be getting any volume change. However, once you cross the solid state, if you enter the semi solid state or the plastic state or the liquid state, basically your volume will be increasing gradually from semi solid to plastic and plastic to liquid by increasing the water content. So, this is by and large a clear picture about the consistency of clay. Now, when a fine grained soil is mixed with large quantity of water, the resulting suspension is in a liquid state, as just now I have told, and offers practically no resistance to flow. So, in the liquid state soil will not offer any resistance to flow. So, basically you will not be getting any kind of strength, it is a kind of soil water slurry. So, that is basically in the liquid state, or it will not be showing, or it will not be giving you any say strength. So, if you want to construct anything on top of the soil which is on top of the this clay soil, which is basically under liquid state, it will not carry or it will not give you any resistance or carry any load. So, that is basically your liquid state. Then the boundary water content between the liquid state and plastic state is called liquid limit. So, now we are defining different limits. So, the boundary water content between the liquid state and plastic state is called the liquid limit. Please try to understand, this is very very important. So, based on these limits, basically you can get the property of the clay soil. In the plastic state, the soil can be molded to different shapes without rupturing it due to its plasticity. As I told you, so if you are really interested in clay modeling, so you should have the soil or the clay under plastic state. If the water content is further reduced, the clay sample changes from plastic state to the semi-solid state at a boundary water content which is called as plastic limit. So, this is the boundary of your plastic state and the semi-solid state. So, that means from the plastic limit to liquid limit, the soil will be exhibiting the plasticity or the plastic state. Up to the semi-solid state, the soil remains fully saturated, and any reduction in the volume of water will result in an almost equal reduction in the volume of the soil mass. A further reduction in water content, however, brings about a state when, with a decrease in moisture, the volume of the soil mass does not decrease any further, but remains the same. The sample changes from the semi-solid to solid state. As I told you, in the solid state, basically whatever moisture content or whatever water content you consider, or if you reduce the water content, if you increase the water content in the solid state, basically you will not be getting or observing any volume change in the soil matrix. The boundary water content between semi-solid and solid state is called as shrinkage limit. So, this is the boundary between semi-solid and solid state. So, that means from between shrinkage limit and plastic limit, the soil will be behaving as a semi-solid state. Now, liquid limit can be defined. It is generally represented as WL and it is defined as the water content at which a soil is practically in a liquid state, but has infinitesimally resistance against flow. So, basically you do not have any resistance to the flow. Liquid limit is defined as the water content at which a groove cut in a pad. So, this is again related to your laboratory experiment. So, basically you have some standard liquid limit device, and there basically you have some small bowl, and inside that you will be putting some soil by mixing with different moisture content, and then you will be cutting the groove with a standard say cutter, and then you will give the blows. That means that whole bowl will be going up and falling down, and then at a then slowly that whatever groove you have cut, that groove will be touching each other, and then based on that we can plot the flow curve, and then that flow curve we can determine the liquid limit. So, this is the laboratory experiment device. Anyway, so the liquid limit is defined as the water content at which a groove cut in a pad of soil by a grooving tool of standard dimensions will flow together for a distance of 13 millimeter under the impact of 25 blows in a standard liquid limit device. So, this is basically your laboratory experiment device. Now, basically what you get here. So, this is your flow curve. So, you take some soil sample, you mix or if you mix different say amount of water, and that means you are varying water content, and then basically you are putting that sample in the standard liquid limit